Hello folks, welcome to one more great section in our great course in mathematics today with great volunteers helping us to understand the chain rule. We are doing the chain rule for functions of multivariables, okay? So the story is like that. You pick a function that takes a real number, t is my variable, and the function gives me the vector x of t. X of t has two coordinates, x1 and x2. Each one, it's a function of t itself. Okay? So for instance, I pick this point t star here, t star, and go apply the function, and then arrive here at x star. Okay? This vector. So it's a vector function. A function that takes real numbers into points of R2. Then over this set here, I apply another function, a function f, capital F, which takes vectors in R2 into real numbers, number z. So z is f of x. Okay? So this point x star, when I apply this function f, I arrive at zeta star, which is f calculated at x star. Okay? So this function gets me vectors into numbers again. And I would like to know what's the derivative of the composite function. Okay? The function that goes from real numbers to real numbers. It goes from Canberra to Sydney to London. So I want to see this function that takes t into z, the composite function. And here's the formula for it. Right? How do you compute? Well, this is the partial derivative of f with respect to the first coordinate, x1, multiplied by the derivative of x1 of t. Remember, x of t has made of two functions, x1 of t, the first coordinate, x2 of t, the vertical coordinate. This is a product plus partial derivative of f with respect to x2 multiplied by x2 prime, the derivative of x2 in terms of t. Okay? You can write this formula like that. So instead of using x1 prime, you write dx1 dt. Instead of using x2 prime, you write dx2 dt. You could also use this, the gradient linear product with x prime. What's the linear product? The linear product of two vectors is given by this beautiful formula here. Right? You pick this vector, you compute the linear product with this other vector, you multiply the first coordinates plus the product of the two other coordinates, the second coordinates. That's called the linear product of two vectors. It's a real number. Okay? This chunk here, it's a real number. And the formula is this, the gradient, which takes the two partial derivatives, multiplied by x prime, which takes these two components. Okay, guys? Hope you understand. Review as many times as necessary. Thank you very much. See you next time.